Hello. In this lesson, can we learn how to complete the square, then use that method to solve these quadratic equations. At first, we can start with monic quadratics, and as we said, monic quadratics are ones which the coefficient of x squared is 1. Like in this case, you see x here have nothing, meaning it is just multiplied by 1. Same case here. But non-monic quadratics are the ones which the coefficient of x squared is not 1, it's another value. For example, here it is 2 and here it is 3. So we can start with the monic quadratics. So for example, if we have x squared plus 6x plus 5 is equal to 0, then we complete the square here and solve the equation. So first, this equation here is in this format, where x squared of course takes on the place of x squared, then b is the coefficient of x, and then the x of course is the same, then plus c, this c is this 5, then is equals to 0. So the first step we need to do is to take the coefficient of x, which is b, we divide it by 2, then we square it like that. Then after that, we put this in this formula here, which now becomes x squared plus bx, this one, and then I put b over 2, then squared, but again I subtract it, b over 2 squared, so that I don't interfere with the general formula or even in the equation, because if I take b over 2 squared minus b over 2 squared, it will be 0. And 0 plus bx, it will still be bx, so we will not have changed anything in the formula. Then plus c is equals to 0, like that. Then I can take this c on the other side, so it becomes x squared plus bx plus b over 2 squared minus b over 2 squared is equals to negative c. But if you check well from here up to here, that is a complete square, because the first value of x squared, of course x is squared, and then this b over 2 is also squared, so that's a complete square, and I can write it like this: x plus b over 2, but now squared, because both these are squared, and if you expand this, you'll get x squared plus bx plus b over 2 squared. So now that we know that part is a complete square, we are only remaining with this minus b over 2 squared, then is equals to minus c, like that. But now this becomes the formula, but can we apply it in the equation here? So if I have x squared plus 6x plus 5 is equals to 0, the first thing is to take the coefficient of x, which is 6. So 6 over 2, but now squared, which becomes 3, but now 3 squared. So in the original equation, I take x squared plus 6x plus this 3 squared, and then again minus the 3 again squared, so that 3 squared minus 3 squared, it will be 0, and it will not affect the original equation. Then I can say is equals to, I take this 5 on the other side the way we did with this c, so it becomes minus 5. And then when it becomes minus 5, then from here you can note from this part here that is a complete square. So I can write it like x plus 3, but now squared. And if you expand this, you will get x squared plus 6x plus 9, because 3 squared is 9. If you expand this, then minus 3 squared, which is 9, is equals to negative 5, like that. But now, since I have a 9 here, I can take it on the other side, and I have x plus 3 squared is equals to negative 5 plus 9. So x plus 3 squared will be negative 5 plus 9 is positive 4. Then from there, I can take square root of both sides. Here, I take the square root of this and the square root of this. So it becomes x plus 3 squared. Square root of it, automatically it will remove the square. So it will be x plus 3 is equals to square root of 4 is 2. But in mathematics, any square root of any number is given as plus, minus, now that value, which in our case is 2. So now that we have plus or minus 2, I'll take the first instance where 2 is positive here, and I say x plus 3 is equals to 2. So x will then be 2 minus 3, which is equals to 2 minus 3 is negative 1. That becomes the first solution for that question. And then the second one where 2 is negative here, so it will be x plus 3 is equals to negative 2. So x is equals to negative 2. Then I take 3 on the other side, it also becomes negative. So it becomes negative 2 minus 3, which is negative 5. And that becomes the second solution of this question. Can we try another example? So in this question, you are given x squared minus 8x plus 12 is equals to 0. You are told to complete the square, then solve the equation. As usual, the first step, we can take this 12 here on the other side, which of course is our c. So it will be x squared minus 8x is equals to, this 12 here is positive, so on the other side it will be negative 12. Then from there, the coefficient of x is negative 8. So I take negative 8, then I divide by 2 and I square, which becomes negative 8 divided by 2 is negative 4. But now squared like that. So I add this one here and I also subtract it so that I don't make any change in the original equation. So it becomes x squared minus 8x, then plus this negative form but now squared, and again minus this negative 4 again, and then squared is equals to negative 12. Don't forget the reason why I'm using negatives here is because the coefficient here was negative 8, so I picked it with the sign. So from there, as you can see from this part here, this one, then it means the whole of this part is a complete square. So I can write it as x minus this 4 because this is positive. So positive multiplied by negative is negative. But even if you don't open the brackets just like that, it will be x minus 4 per now squared. Then this 1 here, if you take negative 4 squared, it will be positive 16. So it will be minus 16 is equals to negative 12 like that. So it becomes x minus 4 and now squared is equals to negative 12. I take this 16 on the other side, so it becomes plus 16. Then from there it becomes x minus 4 squared is equals to negative 12 plus 16 is positive 4. And then to get the value of x minus 4 itself, I need to take square root on both sides. So it becomes square root of that and then the square root of 4. And then it is x minus 4 because the square root of x minus 4 squared is x minus 4. Then is equals to square root of 4 is 2. But we said in mathematics it is plus or minus 2. So from there, I take the first instance where 2 is positive, so it becomes x is equals to that 2 which is positive plus this 4. If I take it on the other side, plus 4, then it becomes 2 plus 4 is 6. And the second instance where 2 is negative, so it becomes x is equals to negative 2, but then I take this 2 on the other, this 4 on the other side, which now becomes plus 4, negative 2 plus 4, which is 2, and that becomes the solution for that question. Can you try these two questions following the same logic to see if you get the solutions, and then we can go to the next step of solving the non-monic quadratics. So, non-monic quadratics are the ones where the coefficient of x squared is not 1. Like in this case, the coefficient is 2. So, how do we go about this? In completing the square, then solving the equation. The first step is very simple. We need to just force this non-monic quadratic to be monic. So to do so, we need to take the value, the coefficient of x squared, and we divide every value in the equation with that coefficient. Like for example, here the coefficient of x squared is 2. So I need to divide them by 2, here by 2, here by 2, and also here by 2 to force it to be monic. So 2 divided by 2 is 1, so it becomes x squared. Of course, now it is monic because the coefficient of x squared now becomes 1, because 2 over 2 is 1. Then plus 8 divided by 2 is 4, so 4x minus 10 divided by 2 is 5. Then is equals to 0 divided by 2 is 0. And then from there, now it is monic. We follow our normal process. So the first step, we take this negative 5 on the other side. So we have x squared plus 4x is equals to here negative 5. So on the other side, it will be positive 5. Then from there, we take our b, we divide it and then square. And our b here is 4. So 4 over 2 and now squared, which is equals 4 divided by 2 is 2, but now 2 squared, like that. Then from there, we add these 2 here, and we also subtract it so that we don't make any change in the original equation. So it becomes x squared, then plus 4x, again plus 2, but now squared, then minus 2, but now squared, is equals to positive 5, like that. Then from there, as you can see from this part here up to here, that is a complete square. So we only need to take this x here, then the 2 here plus 2, then in brackets squared because both of them are squared. Then this negative 2 squared, it will be positive 4 plus 4 is equals to positive 5, this one. So from there, I can take this 4 on the other side. So it becomes x plus 2, but now squared is equals to 5 minus 4, like that. So this x plus 2 squared is equals to 5 minus 4 is 1. So we take the square root on both sides so that we get the value of x plus 2 itself. So the square root of that and the square root of this. So the square root of x plus 2 squared is just x plus 2, because square root of any number, if you square a number, take the square root, it is the number itself. And in this case is x plus 2 is equals to the square root of 1 is of course 1. But in mathematics, we say the square root becomes plus or minus, then the value itself. So now we have x plus 2 is equals to plus minus 1, and we take the first instance where 1 is positive. So we say x plus 2 is equals to 1, but then these 2, we take it on the other side, it becomes x is equals to 1 minus 2, because here it was positive. So it becomes 1 minus 2 is negative 1, and that becomes the first solution for that question. And then the second one is where 1 is negative. And so I say x plus 2 is equals to negative 1. And then I take this 2 on the other side. So it becomes x is equals to negative 1, then minus this 2, which now becomes negative 3. And that becomes the solution for the second solution of x in that question. Can you follow the same logic and try to solve this question 6? See if you understand it. And if you don't, you can leave a comment, you can ask me any question. I'll try to solve my level best. And bye for now. Let us meet in the next lesson.